So when we talk about covalent or molecular molecules or species, meaning that it could be an ion, we want to illustrate that using what's called a Lewis electron dot structure. The Lewis structure allows us to take a look at how the molecule might act or react, and then when we get to Chapter 9, we'll look at its shape as well. So this section, section 8.5, talks about how to draw Lewis electron dot structures. And we'll go through the basic 5 steps right now, do a few examples, and then in the next couple of videos we'll get into some special cases or special circumstances. Step number 1 when drawing the Lewis electron dot structure is to sum the valence electrons from the atoms that are coming together to make the structure. So if we're doing PCl3, we want to look on the periodic table and find the valence electrons from phosphorus, which would be 5 because it's in group 15, plus chlorine, which is in group 17, so it has 7, and there are 3 chlorines here, so that's 21 plus 5, or 26 valence electrons total. Now if it had a charge up here and it were a cation, meaning it had a positive charge right here, that means it would have lost an electron, and so we have to subtract an electron if it had a positive charge here. If it had a negative charge here, like a -2 for example, then we would actually add 2 electrons to it, because it would mean it would have 2 more electrons added to the structure. So watch out for cations and anions there. Next step, take the symbols, and it's often written in order, where the first atom is the central atom, and then these atoms are bonded around it. As for example, in HCN, it would go H, and then a C, and then an N. And it turns out that there's more bonds and things in there, but that's the order because it's written in that order. CO3-2, carbon's in the middle, and the oxygens end up going around it. There's more to that one as well, but that's just examples of that. In PCl3, it also holds to that. P would go in the middle, and then the Cl's end up going on around the outside. Now, if you're stuck on that, it's generally the rule that the central atom is the least electronegative atom. And you know that electronegativity increases up and to the right. And if you look at chlorine versus phosphorus, chlorine is way further right than phosphorus is. So phosphorus would be our less electronegative atom, and that goes in the central portion. Rule number 4, after we've written the chlorines in here, I forgot to do that. Complete the octet. So we've used up 2, 4, 6 electrons here, because each dash, remember, means 2 electrons. So 26 minus 6 means that we have 20 electrons remaining. It's good to kind of keep a running tally of this. I'll move this paper over here, and then move this one back up here, so then we can kind of keep along the way. And so we'll complete the octet here with 2, 4, 6. That makes an octet from chlorine. 2, 4, 6. That's 12 more electrons used up. And 2, 4, 6. That's a total of 18 electrons used up. So 20 minus 18 means that there's 2 electrons remaining. And it says extra electrons go on the central atom. 2 electrons left. So we put those on the central atom right here. And then you can tell that phosphorus now has 2, 4, 6, 8, because remember each dash represents 2 electrons. This chlorine has 8 electrons, this chlorine has 8 electrons, this chlorine has 8 electrons. Check, we're done with that Lewis electron dot structure. But rule number 5, if it's not working, try multiple bonds. So let's do a couple more examples here where we'll go through those 5 steps. PCl3 is one that I just did, and I have that at the top right here. That ended up being the P with the Cl's around it, and then we ended up with a pair of electrons. That's called an unshared pair on the phosphorus here, and then each chlorine had 3 unshared pairs and 1 shared pair with the phosphorus, ending up using up all 26 electrons total and completing the octet for everything. Let's look at HCN and follow these. First of all, follow these rules. First of all, sum the valence electrons. So hydrogen is 1. Carbon is 4, because it's in group 14 right here. And then nitrogen is 5, because it's in group 15. So 4 plus 5 plus 1, we have 10 total valence electrons. Let's go with this, that this is the order that it's written in. And so that means hydrogen is going to be bonded to carbon, that's going to be bonded to nitrogen. If we weren't sure of that, we could also look at the central atom being the least in electronegative. That holds true except for hydrogen, because hydrogen, remember, can only form one bond, and so hydrogen will never be in the middle. So if you want to add yourself like a little exception down, you could say never, ever. There aren't very many alwayses in chemistry, but here's one. Never hydrogen can go in the middle. So here's our HCN, and we've got 4 electrons used up right here, so 10 minus 4 means we've got 6 remaining. Complete the octet? Well, with 6 electrons, if I go 2, 4, 6 right here, I've completed the octet for nitrogen, but carbon, poor carbon's only got 2, 4 electrons around it. And remember, hydrogen just wants to fulfill the duet rule, and so it's done. But still, we're sliding carbon right there. So it's not working if I just put 2, 4, 6 around here, or 2, 4, and 2 more right here. So there aren't any extras to go on the central atom, so I must be at number 5 where it's not working. Try multiple bonds. So let's use 2 more electrons right here, and let's make a multiple bond right here that leaves us with 4 electrons left. So 2, 4, that gives me an octet here on nitrogen, but carbon still only has 2, 4, 6 around it, so it's still not working. So it says try multiple bonds, so let's try multiple bonds again. Let's try a triple bond right here. 2 less, that gives me 2 electrons remaining. So let's see, I have 2 around hydrogen, 2, 4, 6, 8 around carbon, 2, 4, 6. I have 2 electrons left. Let's put them right here. That completes the octet on nitrogen, and bingo, bango, bongo, I now have a Lewis electron dot structure that obeys all the rules, where I've got an octet, and I've got a duet right there in hydrogen, and I followed all my rules right here. All right, last one right here, ClO2 minus 1. So this is an ion, so when we sum the valence electrons right here, chlorine, group 17, would have 7 valence electrons, plus oxygen, which has 6 valence electrons, times 2, because there's 2 of them right here, and then notice it's an anion, so anion, add an electron to it, because remember that -1 means it has 1 more electron in its species. So 12 plus 1 is 13, plus 7 gives me 20 electrons for the structure. And then let's see, we're going to go chlorine as the central atom because it's in the middle, and chlorine is actually a little less electronegative than oxygen, and then we're going to bond the oxygens around it. So following the rules here, often in order, central atom least electronegative, bang, complete the octet is next. Right now we've used 2, 4 electrons right here. We've got 16 remaining. If I go 2, 4, 6, 8, 10, 12, I've completed the octet on the oxygens, but I have not completed the octet right here on the chlorine. Well, it's not working, so what do I have to do? Try multiple bonds. Okay, let's try a second bond right here that uses up 2 more electrons, so I have 14 left. So if I go 2, 4, 6, 8, 10, 12, oh, I might be able to make this happen. Okay, 2, 4, 6, 8, 10, 12. Am I close? I think I'm close. Let's count them all up. 2, 4, 6, 8, 10, 12, 14, 16, 18. I think I've not making it work quite right. Maybe I didn't need this double bond right here. Let's back up here. Let's go to this again. And 2, 4, 20 minus 4, I have 16 electrons left. Let's try it. 2, 4, 6, 8, 10, 12, 14, 16. Oh, I didn't have to use a double bond right there. I miscounted. I'm glad you actually got to see me make that mistake when I could have just gone and put my electrons around it to bond because I had 14 electrons remaining to make it work. Now, since it's an ion, I have to end up putting it in brackets and then putting a little -1 here in the upper right-hand corner to indicate that that's an ion and it has an extra electron. Completed the octets. I didn't even have to do the multiple bonds part. And now you've seen several Lewis dot structures done, and you have to practice some of these Lewis electron dot structure drawings.